Okay, the view that I have that we are looking at currently is called the Tully view. And what that means is, I'll put some things into motion here for you. But with the video that we saw yesterday, remember that it was showing us about a thousand, a thousand or so light years. Um, no, I'm sorry, a billion light years away. All right. That's sort of like going out in any direction. It's a billion light years away from us. This perspective here is 825 million light years away. So here we are located at the central region of this cube in our local what's called supercluster. And I'm gonna stop there. Can I roll it back a little bit? Okay. You can see sort of a shape to this geometry where there's a void, there's a gap here, if you will. And that gap is there as a result of, in the Milky Way, which you can't see if we zoom in, there's going to be the sun here, though, ultimately. But in the Milky Way, okay, well, there's the Milky Way there. And there's where the sun is located in the Milky Way. But from our observational perspective, and looking in either direction from our Milky Way, you see this gap of activity because the material is relatively dense galactically that we cannot see in those directions. So those would be laterally like across the horizon of our Milky Way. Okay, so that's what you have in this particular perspective, where our sun is located here in the middle of our view. Okay, which is ends up being, what you're going to learn soon, is 26,000 or so light years away from the central part of the galactic core. Okay, so that's what's happening in this perspective in our local, what's called supercluster, and and in this web, in all of these threads, these filaments they call them, lies a pretty extraordinary event happening with all the galaxies. Okay, so that's what's called the Tully database. Just some more perspectives on the individual galaxies in our immediate area. There are one, two, three, four of them. Okay, a couple of them are pretty small. The Sagittarius one is the one that's actually on its way, and it is making contact with part of our Milky Way galaxy as we speak. All right, so but some would say that it's actually going to float right through. It's going to go right through our galaxy without even making a great deal of contact. Um, let's see, other ones. These Magellanic clouds are pretty minor features. They're relatively small, relatively dim, as far as I know. Let's be honest. But one galaxy that's going to come up all the time is the Andromeda galaxy. This is one. This is the main galaxy that I want you to know, um, above and beyond our Milky Way galaxy, right? Because allegedly it's the only one that you can see without a telescope. Although the only time I've ever seen this galaxy is through I've seen it through a telescope, but binoculars actually work pretty good as well when looking at this Andromeda galaxy. So it's a spiral galaxy that it's interesting. I was always taught that it was 2.2 million light years away, right? But this database, if I hover over here, you can see in the top left in the blue text in this region it's going to be. So I'm going to stay hovered over here. That's just where the text ends up going. And it's saying 2.8926 MLY, so being 2,892,600 light years away. Right? But it's a major spiral galaxy in and of itself, containing about 200 billion stars. Right? So we'll get some better views of that Andromeda. That's definitely a photographer's favorite as far as astronomy goes. Right? But so these are colossal features. Right? The Virgo cluster is the closest cluster to our own. I'm looking at some other data at the top left over here about how far it is away from our perspective. Okay, so I mean, looks like a spider web of activity, and there's individual ones that are in the database here. Right? Lenticular galaxies, uh, transitional galaxy. We learned about those. SOA. Another transitional galaxy. Yeah, every single one of these kind of reminds me of the activity that we did with the Zoom astronomy site. Right? There's just so many galaxies that are out there. Um, NGC. It's called the New General Catalog. NGC stands for New General Catalog, and it has to do with just a way of tracking galaxies that have been discovered and are placed nearby us. Okay. Um, yeah, so every single one of these, all right, is its own system. All right, so just extraordinary perspective. So more on M31, the Andromeda galaxy. Okay, so one of the reasons it's extremely popular is because it's the closest major galaxy to our own, and it's gargantuan, right? It's every bit as big as the Milky Way, if not larger, right? And in some cases, individual stars have been seen to sometimes erupt, right? To go supernova, right? You can see individual stars happening that far away. Okay, M51. The letter M refers to what's called a Messier object, Messier, okay, named for the French astronomer Messier, who was a famous comet hunter. But in his hunt for comets, he also was able to track along the way 100 plus, 100, maybe 10 or so, 103 rings a bell, but over 100 or so different objects out there, galaxies, nebulas, and star clusters. Right. So this M51 is an example of a colliding galaxy. Okay, one galaxy that's making contact with another one. You can see the spiral that's made contact even. All right, so they can do some pretty fantastic things when they do make contact. A lot of times when they hit each other with the bulk of their mass, they really end up creating a bunch of bright new stars, which is one of the consequences. But ultimately, these two galactic cores could merge into one. All right, so there's several different examples of how we can take a look at merging galaxies. Can bring me just do a quick Google image search. Okay. So what you're seeing here, yeah, they're just fantastic. Um, I mean, I wouldn't not even doctored up. You'll see that some of the same images, for instance, all right, and this is an example of a lesson for another day. Uh, these two, right? These two, I think they call them the owl eyes, but I'm not. Don't quote me on that. But these two, they look differently in some levels of radiation rather than other levels of radiation. So those colors here are popping a lot more because in different wavelengths, such as infrared or ultraviolet or radio wavelengths, right, different galactic activity is sort of showing, is being illustrated at any one of those times. So that's why you can have the same image in multiple different colors, even. Right? There's not any others are standing out to me right away as an example of that, but yeah, but ultimately though these galactic cores do merge with one another, and so that's one of the ways you could tell how long it's been, for instance, since they did make contact with each other, and how far away those galactic nuclei are, those galactic active galactic cores. Okay, all right. So enough of that one here. Okay, Messier object number 81. This is fantastic, reddish and blue. All right, how far away is it? Look at our data. The top left, we have distance from observer, -1 light year. Okay, that's because how far I can. No, I'm not sure why it's showing that as the distance. -1. Okay, because here back on Earth, if I can bring up the land. Okay, back on Earth, and once again using constellations as sort of guideposts, right? And toward the north, northwest. Okay, you have members of the zodiac: Cancer, Leo. Okay, Virgo. We're going to draw an imaginary line through those. You get what's called the ecliptical plane. But so really finding these galaxies is a needle in a haystack. Okay, so it's only with the more powerful backyard telescopes that these can be seen. Right. This is this spoiled here by probably an actual Hubble image that's been patched into what you're seeing here with the software, Starry Night software. All right. Another number I want to direct your attention to is going to be the bottom one of the series of little blue numbers that come up over here. So I'm going to hover over the object. Let's see if I can actually open this up. Now that brings up something else in the background. Back onto, I want M81. Oh, okay, I got a little disoriented here. Bode's Galaxy. Maybe that is another name for M8081. I thought it was. Okay, can look that up just to be sure. M81. Bode's. Sure enough, that is the case. Okay, so Bode's Galaxy is another name for Messier object number 81. All right, and so its companion, potentially, all right, an irregularly shaped galaxy. But okay, so which brings me back to this number here. See that number that says 6.71, 6.71 for the background galaxy. Now why there is a, I'm sorry, I don't know what the 6.71 was. So the 8.5. You might have remembered me saying in class something about the bigger the number, now here it is again though. It's that 6.71 number coming up. But anyway, okay, let's call it 6.71, Bode's Galaxy. What that means is the smaller the number, the brighter the object. All right, the larger the number, the dimmer the object. So you definitely need a telescope to see this galaxy, but you don't need the most powerful telescopes that are out there to see that one. This is one that you can buy from, I don't want to say Walmart, but you could probably buy one from Walmart that would pick up that galaxy. Okay, I'm not trying to bust on Walmart today at least. But Okay, another really important one is the Whirlpool Galaxy. I want you to be familiar with that one. 51. All right, so that's where we have these two ones that are interacting with each other. Okay, the Whirlpool Galaxy. Um, yeah, fantastic. So this apparent magnitude is 10.15, so it's going to be a lot more dim, more difficult to see. All right, here we're looking at 27 million light years away. All right, so once again, using the members, using these constellations as a reference point. All right, so that's where we're seeing galaxies in the sky. And there's a lot more out there besides just that. All right, that's just what happened to be present in this database that I wanted to show to you. Okay, back to this view. Okay, M104. All right, the famous Sombrero Galaxy. All right, at a 9.5, this is one of the most beautiful galaxies because of just the perspective that it has. This image does not do it justice at all. Okay, but this colossal spiral galaxy, all right, where the spirals are actually they're not really well separated from one another. All right, but let's bring up the Sombrero Galaxy. Okay, just the most fantastic images ever imaged. All right, so here's a good example too, though, of the Sombrero, all right, in visible light and the Sombrero in infrared light. All right, so we can see different activity levels of different places, right, in that same galaxy, with the same image, right? So two different kinds of cameras are imaging the thing at the same time. But that is just eye candy if I've ever seen it. Okay. Okay, all right. Well, that's kind of a walk through some of the galactic material. All right, there's more specific information that we're going to learn soon about our Milky Way in the next section. But I wanted that to be able to finish up one last time with the local superclusters. Okay, so hopefully we're starting to get an idea of scaling down the universe into something that we can almost begin to wrap our brains around. All right, that is such wishful thinking, I realize, but it's something we want to try to do. Okay, all right. Wishing you all health and clear skies to do some stargazing. Thanks, folks.